Day 12 of 60. Today we are building a full distributed tracing pipeline with Jaeger and OpenTelemetry. By the end of this video, you will understand how traces flow from your application code through the Jaeger collector into storage, and how to use them to debug production latency issues. Let us start with why tracing exists. You have an API endpoint that is slow. Logs tell you something happened but not where the time went. Metrics tell you latency is elevated but not which downstream service caused it. A distributed trace gives you a waterfall view of every operation in a request path, across every service boundary, with exact timing. You see that the payment service spent 1.8 seconds waiting on a connection pool, or that the inventory check made 3 redundant database queries. That specificity is what makes tracing essential for production debugging. Jaeger architecture. For components. The collector receives spans over OTLP gRPC or HTTP. It validates them, indexes them, and writes them to storage. The query service exposes the Jaeger UI and an API for searching traces by service, operation, tags, and duration. Storage is pluggable. Elasticsearch gives you full-text search on span attributes. Cassandra handles higher write throughput. For modern setups, you skip the standalone agent entirely and send OTLP directly from your application to the collector on port 4317. That removes one network hop from the pipeline. Now let us instrument a Python service with OpenTelemetry. You create a tracer provider with a resource that identifies your service name, version, and environment. You attach a batch span processor with an OTLP gRPC exporter pointed at your Jaeger collector. Then you get a tracer and start creating spans. Each span has a name, attributes, and optionally events. When you call start as current span inside another span, the SDK automatically creates a parent-child relationship. The batch span processor queues spans in memory and flushes them in batches, so your application code is never blocked waiting for span export. For production, tune the batch size and flush interval based on your throughput. The defaults of 512 spans and 5-second delay work for most services under moderate load. Context propagation is what makes distributed tracing distributed. When service A calls service B over HTTP, the trace context needs to travel with the request. The W3C Trace Context standard defines 2 headers. The traceparent header carries the trace ID, parent span ID, and sampling flag. The tracestate header carries vendor-specific metadata. OpenTelemetry handles injection and extraction automatically. When you instrument your HTTP client library, outbound requests get the traceparent header injected. The receiving service extracts it, and its spans become children of the calling span. One trace ID, spanning multiple services, visible in a single Jaeger waterfall. Sampling. Tracing every single request at high throughput generates massive data volumes. Head-based sampling decides at trace creation whether to record it. A 10% sampler drops 90% of traces before any span is created. It is cheap but you lose visibility into rare errors. Tail-based sampling is smarter. It buffers spans until the trace completes, then applies policies. Keep all traces with error status codes. Keep all traces over 2 seconds latency. Random sample 5% of the rest. The OpenTelemetry collector runs this as a processor in its pipeline. The trade-off is memory. Every in-flight trace must be buffered during the decision wait window. In production, I run head-based at 25% for baseline and tail-based at the collector for error and latency capture. That combination never misses the traces that matter. The last piece is connecting traces to logs and metrics. Inject the current trace ID into your structured log entries using a logging filter that reads from the OpenTelemetry span context. Now Grafana can deep link from a Jaeger trace to the exact log lines produced during that span in Loki. For metrics, Prometheus exemplars attach a trace ID to individual histogram observations. When you see a P99 spike on a dashboard, you click through to the actual trace that caused it. That three-way correlation, metrics to traces to logs, is how experienced SRE teams go from alert to root cause in minutes instead of hours. Day 12 done. Tomorrow we tackle SLOs and error budgets.